Hello everybody. Welcome back to some more live streaming. Today's topic is Arduino, and more specifically designing and testing circuits using a circuit simulator. So what I thought we would do as an exercise is basically prototype a simple product and kind of talk and walk through the process. We'll start by, I guess the first thing I want to introduce is fritzing. I just want to touch on fritzing. It's not the one I'm going to use to build the final thing we're going to do tonight, but it is a good tool for certain things, and I do want to mention it. So I have it installed already, and I'll show you what it is and how it works. And this other tool we're going to look at is pretty much the same kind of thing, but it's by a different company, and it's in the browser actually. So when you start up, you've got kind of a big screen, but you can just say new sketch. Oh, I guess I'm already in a sketch. So there's a couple tabs. There's PCB, schematic, and breadboard, and code. And so I believe you can actually do simulating in fritzing as well. So it's also a tool, but I just want to show you because fritzing is really good if you want to share a breadboard design with somebody. So, oh, I guess it couldn't find any parts. Well, then the only thing I want to show you is a couple pictures of it before I start using the other one. So, fritzing is good if you want to make diagrams like this, or wiring diagrams like this to show people how to wire up projects. So, the one I really want to show is called TinkerCAD. And TinkerCAD is owned by Autodesk. And TinkerCAD does a few things. It lets you 3D design things. And so it's kind of like a SketchUp, but this is really useful if you want to do 3D printing. And for example, if you wanted to build an enclosure for your product, you can build like an Arduino enclosure to put, like, let's say you wanted to make a birdhouse and put a Raspberry Pi in it or something. You could do that with this. And you can export it, and yeah, you can export it to an OBJ, an STL, or an SVG. So, oh look, you can even export it directly to a 3D printer and have them 3D print it and mail it to you. So yeah, you can get an STL and you can put that in your own 3D printer or 3D modeling software. So I just wanted to show you that, but the one that I really wanted to look at is not the 3D designing tool, but the circuits. And by the way, they do have lessons, and so you can learn how to use it, and they show you how to learn the 3D modeler and how to use the circuit designer and all that. But I basically want to show you the circuit designer because I'm not sure a lot of people know about this, and it's really nice if you don't have all of the parts to test it out, or like if you don't even have an Arduino. So you just drag and drop. We'll start with an Arduino. And what do we want to start with? So you got a few basic sensors here. You got like a motion sensor. A PIR is a infrared sensor. It's good for if you want to do, like, let's do a quick example of a motion detecting alarm system. And so we only need a couple parts here. This here is a piezo. It's basically a buzzer, and it'll buzz if you send it signal. And this is a motion detector. So what we'll do is basically detect motion with this thing, and then buzz with this. and I'll show you how we can do that. So here, if you put your mouse right on the tip, let me see if I can get these a little closer. So it may be hard to read, but it tells you that this pin is signal, this pin is power, and this pin is ground. And so we can wire it right up to the Arduino like this if we wanted to. But it gives you breadboards too. So you can show people how you would wire it up on a breadboard, and I'm gonna do that. So let's see, how do I undo this one? There we go. Now let's put this one in the ground rail, and let's wire up the Arduino to the breadboard. Okay, and then a 5-volt power here, and we'll plug this one down here actually. And so this same thing with this one, this piezo buzzer is going to have a negative and a positive, so the negative is going to go to the ground rail. And what we can do is actually color them too. So they use black a lot for ground, we'll use black, and same thing here just to make it clear. We'll put all the grounds as black, and 5-volt we'll do red for power, and positive will come down here. And same thing with this one, power comes on the power rail, and we'll make them red. Mythic says hello. Hey Mythic, you've joined like every single night, and that's really awesome. You ever done any Arduino stuff? And we need a signal, so the signal is going to go into the Arduino, and we can just pick any pin we want. So signal is basically going to be an output from this. Whenever there's motion detected, it's going to send a signal out of here, and we want that to go into a digital pin. We'll just pick digital 8. And the signal, we'll just make it, I don't know, we'll make it pink. Well, that's a little hard to differentiate. Why don't we make it orange? Okay, so we've got the signal there, and then actually we don't want the power for the piezo buzzer to come here, because then it would just always be on. It would just always be buzzing. So we actually want the power to come from another pin. So we'll use the Arduino to control the in and the output here between these two things. So our circuit is basically done. It's not the prettiest thing, and you can move these around. One thing that you can do in Fritzing that you can't do here, as far as I know, is actually curve the wires. You can bend the wires in an arc, and that makes it really nice to design things. Fritzing is better at mocking up the visual design, but I like doing this one in the browser. So now we've basically got our circuit designed. We can export it, and you can actually export it to an eagle.brd file. And EagleCAD is something you can use to design PCBs. So basically, if you wanted to take this prototype that you do on a breadboard and convert it into a PCB that you can put inside of a plastic enclosure, you can use EagleCAD to do it. So this basically exports the circuit that you can start working with on your board there. And Easy EDA is another one. Easy EDA is a good one if you want to do it all in the browser. And I have some stuff in there, but I'm not logged in, and I'm not sure what my account is. I did some very tiny prototypes, but they give you some examples. Oh no, that's the... Anyway, you can design the circuit in there and print it out on a PCB. If you don't know what I mean by a PCB is basically the printed circuit board. And you can make your own. You can buy the parts, and you can actually acid etch your own. So you basically buy... Some people do the acid etching in art, but you basically print out the black and white on paper, and then you transfer it over to the PCB board, and it starts out completely covered in copper, and you can buy these copper boards, and then you basically transfer it over. I think you use like an iron or something, and then you drop it in the acid, and it burns away everything except the parts that you covered up, basically. And so you can actually print your own PCB. You actually have to drill it and everything yourself too. So that's a lot of work, but it's cool that you can do it yourself. The other option is to use something like JLC PCB. And this will, they'll basically, for $2 you can get 10 boards made, and you can get your own PCB boards printed out. So you basically design your file in EasyEDA or EagleCAD, and you upload it, and they print it out on actual plastic boards and send it to you. I guess it's fiberglass. And so that's how you can get your own boards made from a circuit like this. So Mythic asks, do you happen to know of hardware I should get apart from Arduino? And that's kind of the point of this whole video, is to show you how you don't have to buy any hardware to get started and to start playing around. Obviously an Arduino, if you have one, would be good, but then you would need the sensors. Like if you wanted to mock this up, you'd actually have to buy a PIR sensor and buy a piezo buzzer and buy the wires and buy the Arduino and buy the USB cable and buy the breadboard. But if you do it all here, you can mock it up and test it out without buying anything yet. And you can also look, if you go up to the top right, you can do a component list, and it'll actually give you the full list of everything you need. And you can export this as a CSV, and the BOM stands for Bill of Materials. So you can basically output all the things you would need to build this: the Arduino, the PIR, and the piezo. So when you have something like this, I want to show you can do start simulation, and it basically, on the left here, you can see it plugs in the USB on the bottom left and basically turns on the Arduino. But it's not doing anything right now, so we can click on the code tab, and it gives you this block system that's kind of like Scratch, but I've never used it and I don't know how to use it. So if you don't know how to code at all, you can play with this, but I actually want to go into code mode, and I just want to see the actual code. So this basically gives you the Arduino editor, and down at the bottom you've got a serial monitor, so you can, when you run it, you can check the serial output if you have any. You can download the code as an .ino, which is an Arduino sketch that you can open up. And the libraries, awesome. So if you need to include any libraries like NeoPixel, which okay, so I want to show you this example, and then the goal for tonight is going to be to design and mock up a wearable product. Basically, you can use an Arduino, really, really small, that goes inside of clothes, and then you can wire up little flexible LEDs and stuff. And so I want to design something that will have like tilt sensors on your arm, where you can move your arms around, and depending on where you move your arms, the lights will light up differently and things like that. So that's what we're going to kind of try and mock up. But this is going to be our simple example right now, which is just what we're working on now is, this is a, so okay, look, we can add annotations, maybe this will help. So this is going to be a motion detection alarm system. And so that's what this is, and then I'll add an annotation here that says this is the buzzer, and this is the infrared motion sensor. I guess I'll put PIR in case you don't know what it is. Okay, so now you kind of have some labels and we know what's going on. That's cool. And that's just what this is in general. So from here we can go back to the code, and let me see, I want that off. Let's move this over here. And so we need to do a setup and a loop. If you've never done Arduino, there's two parts. Setup that runs once and loop that runs forever. And so at the beginning we need to set what these pins do, and we're using digital 8 and digital 9. So we need to set the pin mode on those, on digital 8 and digital 9. And so 8 is coming from the PIR sensor, so that's going to be an input for the Arduino. And then we want to send signal to the buzzer, so 8 is going to be output. Okay, and then that's all we need to do for the setup, I think. We'll find out. And basically we want to do something like if, I'll write the pseudocode out first. So we'll say if motion detected, then we will buzz the alarm. That's all this is going to do. So we can say if digital read, we need to get the value from the motion sensor. If it is high, meaning it's triggered. Oh wait, what we need to do is if digital read equals high, and then we're going to do something, and that something is going, that something is going to be buzz the alarm. By the way, let me make this maybe a little bigger. Okay, and then we're gonna buzz the alarm. And all we need to do there, in this case, is digital write to pin 9, the high signal. Otherwise, we'll digital write low, and so it won't buzz the buzzer. Okay, so this code should work. Let's go ahead and try and run it. We'll go do Start Simulator. Okay, so now let's hide the code, and you can see it plugged in. It plugged in the USB thing, and there's a little power symbol, so it's running, and it tells you it's been running for how long it's been running up here. And so you can actually control the inputs. We want to simulate it now. So if we click on the motion detector thing, we can see that this is, I'll move this annotation. Oops. Move. Oh, maybe I need to stop the simulation to move the annotation. Okay, so that's the infrared sensor. Buzzers over here. Okay, let's restart it. So when you click on the sensor, you can see that this is like its field of vision, as if it was pointing out into a room, waiting to try and detect motion. And this, if you click in there, you're going to trigger a movement, basically. So let's say, boom. Make it quiet. You can kind of hear the buzzer going. And so click on it again. And so what happens with the PIR sensors is when it detects motion, it'll basically send the on signal for about a second. So when it detects a signal, it lights up red, and you'll see the two little red dots show up on the PIR sensor. And I'll click it again, and you can see there's two red dots signaling that it's been activated, it's detected motion. And the buzzer shows the sound signals and it actually makes a sound. You can hear it, it's kind of nasty, so I'm not going to play it very loud. But that's how it works. So we basically simulated it, and we basically verified that our circuit idea works, and that if we were to build this with a real breadboard, it would function as expected with this code. And so this is our code, and we can say download code, and we'll actually save the .ino. So I'm gonna go, oh, it just saved it to my download folder, I guess. Now, I'd like to put it in a different folder, so let's create a new folder. And let's see, we'll call this Arduino sketches. And where is it? So the name that it creates really weird names by default. So this is actually our motion alarm. Okay, so we've got our code, but now we want to export this circuit so that we can see it and rebuild it. So I wonder if we can export it as, let's see, zoom to fit. Okay, now can we export it as just like a PDF? Or do we have to export? So actually, I'm going to also export the bill of materials. So I grabbed the bill of materials. We'll probably need that. And so I'm actually going to rename this folder from Arduino Sketches to Arduino Projects. And inside of that, I'm going to create a new folder. And this one's going to be called the Motion Alarm. And then the sketch is going to go in there. And the bill of materials is going to go in there. So now we know what sensors and things we need. We've got the code, and we can go here, we can say export, and we'll download the eagle.brd. Okay, so let's rename this. Oops. Downloads, Arduino projects. Let's rename this to breadboard design. We're going to put all that inside of the motion alarm folder. So this should be all we need to reproduce the project and share it with other people and go to the next steps. Like if we wanted to turn this into an actual product, then there'd be a couple more steps. So let me see if I can open this BRD file. I don't think, let's see, does Fritzing support BRD files? Let's see what programs support a BRD file. It said it's an Eagle file, so EagleCAD. EagleCAD is also an Autodesk piece of software, but it is not free, is my understanding. So Eagle is really, $100 per year. So if you want to do like really, really high quality professional PCB boards, then EagleCAD is the way to go, and you can export this to EagleCAD files. But if you don't have that, you can use, I showed you Easy EDA. And so you can design your own for free online in the browser, just like I did here in the browser with this one. And so, like, here's an example of the ESP8266. And so you don't see, you can see that this resembles the actual board because it is the design for the actual schematic. This is the circuit. This is the circuit design, but you can also do the PCB. Yeah. Okay, so we exported that. I wanted to open programs that support the BRD files. Does Easy EDA support BRD files? Yeah. Yeah, so it looks like you can import that BRD file into Easy EDA. So let me actually sign in. I think let me see if I can sign up real quick. And let me generate a password real quick. Okay. Sorry, I wasn't planning on going in here, but I think it's worth to show you real quick. Geez, storefronts? They all look like storefronts to me. Bus. Alright, let me in. Okay, I think I'll have to go check my email real quick, but I can do that on... Okay, no, great, it let me in. So now that we're in, let's see if we can import that BRD file. So let's go ahead and create a new project. We're going to call this one, well, let's call it the motion alarm. Okay, go ahead and create the project. Okay, so you can do PCB and schematic, and they're slightly different. The schematic is just the electronic schematic, and the PCB is actually the design of the physical board itself. So let's see, you can do schematic, and in our case, we put you got like a power. This isn't the part I really wanted to show, but I did want to see if we could import our, here we go, image? No, no, that's actually an image. I actually want to see if we can import that BRD file. No, let's see if we can go back. Okay, so we did PCB, or we did schematic. Okay, so this is the PCB, and here we might be able to import, no. So maybe it doesn't allow, oh yeah, here we go, Eagle, open Eagle, import file, and we want to import our BRD file. Yeah, and there it goes, it recognizes the BRD file, so that's our breadboard design. We'll go ahead and import it. There we go. So this is the schematic that it generated from our thing we made here. And so this is the breadboard, like if we, or the PCB, if we were to actually go get it printed out and solder it together ourselves. This is how it came out of the box. Now we could design it ourselves. So it's got all these pins because all these pins match the Arduino, but we actually don't need all of them, and so you can actually see that all of those are attached to this little Arduino board here. And considering you don't have to use the big Arduino, and if you were going to do your own thing, you wouldn't really want it. You'd probably do it with an ATtiny, and you can actually, they actually have the ATtiny here in their part list. So, for example, you wouldn't want to use the Arduino for a project that's that simple. You'd probably use the ATtiny, and you would like hook up this one to that pin, this one to that one, and then like the power and ground over there. Something like that. That's not the exact wiring because I don't know the actual pin I/O for the ATtiny, but it could handle this. And then you wouldn't need this whole Arduino. And then on your breadboard, so actually let's do that. Now that we did it with the Arduino, let's delete that, and then we've got the ATtiny. So now I actually want to export the BRD. Now hold on, this is annoying me. I need to change my preferences so that it asks me where to download each file. There we go. Okay, now this we're going to rename to Motion Alarm ATtiny. And then we're going to put that in our Arduino projects and inside here. So now we don't have the big, bulky Arduino powering this whole thing. And in fact, we could, at this point, even eliminate the whole breadboard and wire up these things directly like this. And so power would go there, and then another ground would go there. So you could even do it like that. Yep. So there's like a minimal circuit, and we'll see if there's any differences between these. So let's put this one in. Downloads, Arduino projects motion alarm. This is going to be motion alarm minimal. And we'll see, because it automatically eliminates the breadboard, I think. So there's no need to eliminate it here, but and then what we have here is basically, this is our piezo. This circle, that's our piezo thing, and this would be our PCB board. So it gives us a little square to work with by default. And then the PIR would get wired in, like, let's say we put the motion sensor here and it would face outward right here. And then the buzzer could just sit inside of it like this. And then we could this whole Arduino can go away. And this would be our PCB, and you would actually solder on the PIR sensor right here, facing outward. The buzzer would just live inside, and you could 3D print a very and the ATtiny actually. My cat just jumped in the dresser. Okay, you can put the ATtiny right here on the breadboard, and the piezo right there, and you could put maybe a battery. You could add a battery right here, and then a 3D print rectangle enclosure to put the whole thing in, and just leave a hole open for the sensor. So that's how you would design the PCB, and you could get it printed, and then back in TinkerCAD you could design the 3D printed enclosure for it. You could go back here and like here was a planter that I tried to make I don't know, like 9 months ago. So you could design basically a little 3D enclosure and 3D print it out yourself, and then mount your board, and you have basically a product at that point. So let's close this. I only want to try opening the other board files that I exported just to see how it looks. So we made one with the ATtiny. And actually, let's go back here. So if we did the ATtiny, it would need a battery. It would need a battery, and it would need a 5-volt regulator. So we can do this. We can add a 9-volt battery, and then we can add... Well, we could add like a power switch too, but we don't want to get too fancy, I guess. So 9-volt battery that we would wire up to the power in the ground. And again, these wirings aren't exact for the ATtiny. Did it just let me do a curly one? Oh, it did. Look at that. Well, it's not curly, but you can make multiple joins. Oh, so that's how you can do it. Okay. Okay, that's cool. That's good to know. That makes it easier if you want to diagram things out. It's getting hard to connect. Come on. There. Oh, I missed it. Got it. Boom. Okay. So if you wire it all up properly here, and actually we would need the 5-volt regulator too. Regulator. Okay. Am I back? Am I back? What happened was the cat jumped on the off button on my computer. And my whole computer started shutting down. Now I'm not sure if I'm back and you guys can hear me. If you can hear me, give me a signal. I'm trying to get everything back open real quick.